It is 7 o'clock, which means it's time to start modeling stuff in Fusion 360. And it'll be a good one. We're picking up where we left off on last week's class with our automatic window blind contraption. So last week, it's a little like, I don't know, season recap or project recap that you get at the beginning of the episode. So last week we drew this nice little stepper motor here, and then I gave you some homework of going to find a couple of additional models to add in here. We'll use those later, and I'll share those links later with everybody. But we should be able to get away with drawing most of this without those links. So, excuse me. I'm going to go ahead and close this file because we're not going to use that right now. And I'm going to start a brand new file. So I'm going to come up here to my new design tab plus button here. And if I just click on that, I got a brand new design here, and I'm going to save this right away. This is probably a good practice to be in, although I don't do this very often. I'm going to save this in my automatic window blinds project. So I've got this project that I called automatic window blinds, and I've got a whole bunch of stuff in it. You will just have the 5-volt stepper motor that we drew last week in your automatic window blinds project. And I'm going to call this my blinds control or something to that effect. Alright, blinds control, and I'm going to go ahead and say save. And now, the main reason I'm doing this, man, I got a frog in my throat or something. I got to drink some water, excuse me. All right, so we've got our main document component is no longer called unsaved, and the main reason I just decided to save that right now is because I'm going to be referring to this main document component, and I wanted to be able to refer to something that wasn't called unsaved. So I went ahead and saved it as blinds control, and that'll be phenomenally adequate. I am now going to create a new component. So a lot of times we start by creating sketches, but this particular project is going to be kind of a whole bunch of different objects. So I like to try to keep things as organized as possible. And in this project, the way I'm choosing to organize things is by separating them into their own components. So I'm going to go ahead and say create and then new component. This component is going to be called the drivetrain. So all the drivetrain stuff, including our motor and some gears that we're about to make, is going to be inside of this component here. So I'm going to go ahead and say OK. So I've got this drivetrain component now, and you can see that it is made that the active component, and that is indeed what I want, because now I want to start putting other components inside of this drivetrain component here. And the first component that I want to put in there is our 5-volt stepper motor file that we made last week. So if you open up your little window browser, I don't even know what to call this, data panel, I guess we could call this. And we can see that we've got our 5-volt stepper motor here. If I right click on it, I can say insert into current design. And that'll go ahead and drop that motor in to our into our drivetrain component. Now I do want to do one thing. I just want to take this and I want to flip it around. Well, I've got this move tool. I'm just going to spin it 180 degrees. So I've done this so in my navigation cube, the shaft of the motor faces towards the top. So towards that top surface. This is kind of a moot point. It's just, I guess, for organizational sake and having some sort of orientation of the world. We can just assume that this world in Fusion 360 has gravity, even though things don't really fall. So I guess Fusion 360 does not have gravity. It's a zero-G world. All right, so we've got our motor in, and now we need to make some gears. And there is a fantastic way to make gears really easily in Fusion 360. And that's with an add-in called Helical Gear Plus. So we kind of introduce some of you to add-ins here. If I come over to my Utilities tab, and I go ahead and click on the add-ins menu, and I come to the Fusion 360 App Store. Now it's going to open up a browser. Unfortunately, it's going to open it in another window here. I can just switch that over. Actually, no, I'll do this. We'll bring it right down here. So it will take you to the internet, which is a series of tubes in which you can download stuff from. And the thing we want to download, and we can just type it in the search bar here, is if I just type in gear, but we want Helical Gear Plus. This is the good one, because you can make all kinds of gears with this. The Helical Gear Generator is a fine option, and it would work for this project. However, you can't make worm gears with that gear or with that plugin, so I really like this Helical Gear Plus option. You can also make gear racks. It's a super useful plugin. And then we just have to say download. Oh, and I gotta sign in. Oh yeah, let me pop over real quick. So, YouTube is right up there.
Thank you. Oh, now I see it.
Yeah, so we just had a question about the utilities menu here. So we kind of started in the solid menu here in Fusion. And there are a couple of different, I guess I could call these workspaces across the top here. We did some experimentation in the Surface workspace a few classes ago. Today we're going to get into the sheet metal workspace, hopefully. But there's also a plastic workspace. Most of this plastic workspace has stuff that you can't use or is the same as the solid workspace. Go ahead, Mike.
Okay, is this the same one we downloaded back in November 15th?
Probably.
Okay.
Yes.
So I had a Helical Gear, but I didn't know if it was Helical Gear Plus. But now I see the download file says Helical Gear Plus Win64 MSI.
Cool.
November 15th.
Yeah. What's up?
I'm not finding it.
Oh. So, yeah, Fusion 360 App Store.
I'm not getting to the App Store. I don't know why. I think I don't have a working thing. Nope, well, we're at it.
It's like, there we go, yeah.
Okay.
Now if So, once we get to the page, we gotta sign in, it looks like. It doesn't like me. Oops. You have to use the correct email address. Imagine that. And then your correct password. Let's try that again. And then it will download. Download is a wonderful thing. And then I believe we just have to say open. I believe that's how we do this. Gosh, now I don't remember how to add a plugin. It's been too long since I did this. I forgot we were going to have to do this in this class.
It's an MSI file, which is a Microsoft install file. Just double clicking should install it.
I did not get an MSI file. I got a PKG file. So let's see if it tells us how to do this here. Double click the downloaded installer from the Autodesk App Store to install the app plugin. Did you guys at home get an MSI file, or did you get a PKG file like I did?
I'll be honest, I still haven't installed the last time that I
Okay,
installed
cool.
this project,
Right on.
so I haven't had to bother with it.
Okay. Yeah, I keep getting a PKG file.
Yeah, PKG, like you did.
Okay, cool. Well, and if I click show in folder, ha ha ha. You know why? Because we got to select Win64 here. So for some reason it defaulted to Mac OS. And if we switch over in the Helical Gear Plus page, so you can see Mac OS was blue. If we switch over to Win64 and then we hit download, there's our sweet MSI file that it'll download.
Two-step verification.
And now if I show that in my folder, I can double click, and here now I can say repair, reinstall. For you it'll probably say install, but let me just bounce over and help somebody out here in person. No, you're good.
I got a 6-digit passcode for verification.
Oh. Enter the security code generated by your authentication app.
I've never done
Try going back with the little blue arrow.
that. Alright.
Try go back again. Maybe remind me later instead of getting
Bingo.
started.
I'll do that.
Sure, you read all those agreements, right? Sweet.
Thank you.
Yeah. We just had somebody here who was Autodesk was trying to get him to do two-factor authentication, which is probably a good idea, but not right in the middle of class. Doesn't Autodesk know we're trying to learn things? All right, so we'll just have to install that. Now I'm gonna go ahead. Should I repair or reinstall? Let's try it. So yes. And then it's gonna do magical stuff. And then success, your project has been installed. Your product has been installed. Crack open the champagne. Get out the cheese and crackers. Because now, hopefully, you will be able to use, you will see in your Create menu, that Helical Gear Plus option. Raymond, do you see the Helical Gear Plus option? I think you were downloading this brand new, right?
Oh yeah, I saw it, but it's not popping up on the design.
You might have to restart Fusion.
Okay.
So give that a try. See if it's not popping up right away, you can restart Fusion.
Okay.
That's where I am too.
Okay, cool. Yeah, try that. Try restarting Fusion. Because if you got the success pop-up window, my guess is you just need to restart Fusion, and then hopefully we'll be good to go.
I got Fusion. I didn't restart it.
Yeah, I would.
Restart.
Yeah. Well, you don't have to restart your computer. You just have to close Fusion and then reopen it. Okay, cool. And then we'll cross our fingers here.
Okay, Fusion is starting back up again.
All right, fingers crossed. Feel like we need like a drum roll or something like that. I need sound effects that are part of this, that are part of the live stream. So it should be in your Create menu when you're in the solid workspace, all the way at the bottom. Success here in class? Success? Still starting?
We went back to those.
That's starting up.
I'm getting select your plane.
Did you choose it? Choose. Oh.
I don't know what. I got to do it. Helical Gear.
Hey, cool. All right.
Yeah.
Excellent. All right.
Just saying, okay.
Helical Gear. Success, Raymond?
So what is that? Menu again?
In the Create menu, all the way at the bottom.
Yep, I got it. Helix.
All right.
Helix Plus.
Helical Gear Plus. So let's go ahead and choose that option. And we will get our Helical Gear window right here. So this window, there's a lot here, and we'll kind of talk a little bit about some of it. So the main bits here are going to be the module size. So the module size is going to be like the size of the teeth of the gear. So 3 millimeter module size will give you teeth that are 3 millimeters in thickness. I think I'd go as low as 2 millimeters for a 3D printed kind of gear, but I probably wouldn't go much smaller than that unless you're printing with a SLA machine. If you got a fancy resin printer, then you could probably get much smaller and have good results, but 2 millimeters, I think I get good results in my 3D printed gears. The helical angle here, actually, let's go ahead and turn on the preview checkbox. So if we turn on that preview checkbox, we get a little version of this gear here. The helical angle refers to the angle of the teeth of the gears. So you can, and I often do, like to choose this herringbone option. And these herringbone gears are great 3D printed gear. It's difficult to machine this kind of gear, but if you're just 3D printing things, the helical gear is nice because it's not going to, walk on you. It's not going to move up or down as it's moving. However, for our purposes, we can't have a helical gear just because of the way we have to assemble this thing. So I'm going to go ahead and change this to 0, and I'm going to turn off the herringbone option. I just kind of wanted you to know that it existed. $16 is a good amount of teeth for this particular project. So we're going to leave that as is. And also this 10 millimeter width, the next option down is a fine option as well. Although I guess we could go down to 8 millimeters if you wanted to. Something you'll notice, even though we're drawing in the default unit of Freedom units, the Helical Gear Plus recognizes that there's international standards out there and it abides by them. I believe that we can type inches here. So we can override those international settings like good red-blooded Americans would and turn those into inches if you want to. However, I'm just going to leave them as the metric units that they were, and I will let you make your own decisions about how you want to live your measurement life when using Helical Gear Plus. There is an advanced tab that has a whole bunch of stuff here that, I'm not a gear expert by any means. So some people, I'm sure, could tell me what this pressure angle means. I believe that's the angle of the slope here, the slope of our gear. In fact, let me try changing this. If I change that to 40, yeah. So that is that angle of the slope of the gear. I believe 20 degrees is a pretty standard. A 20-degree pressure angle is a pretty standard measurement for that tooth, and I don't see a reason to change it because the default, I'm sure, will be fine. The backlash is the amount of spacing in between your gears. So if you're going to have gears that mash with each other like we are, you could change the backlash so there's a little bit of play in there. However, I have been leaving this at 0 and having good results. So the 3D prints, they end up shrinking a little bit. There's just a little bit of shrinkage in your 3D print. And I find that amount of shrinkage that I get on each side of the gear when there's two gears meshing with each other, like we're going to have them, that gives enough play in between the gears that they move around really nicely. The last tab that we'll bounce into here is this position tab. And this is pretty handy. So I can specify a plane that I want this to appear on. So I can click, say, the plane that represents the top of our motor kibble a bit here. You know what? I bet I have to turn off my preview in order to do that. So yeah, if I turn off in my settings, if I had this preview turned on, but now I can't see that face because it exists somewhere beneath my gear. If I turn off that preview button, now I can real easily see this face right here. And then I can also select a center, and I can center it on one of these circles as well. And now if I go back to the settings and turn on the preview, now it's nicely centered over the center of my motor there. All right, cool. I'm going to go ahead and click OK. So it has put our, it's kind of interesting. I thought because we had this drivetrain, our active component, as our active component, it would have made this helical gear component inside of our drivetrain component, which is what I wanted it to do, but it did not. So I'm just going to go ahead and drag this into that component now. Will it let me do that? There we go. So I just dragged and dropped that on top of the drivetrain icon here in my browser. And now I can see that in full view, which is nice. So something that this is missing is it's missing the hole in it for our motor shaft. So let's go ahead and add in that motor shaft opening right now. So I'm going to go ahead and change over to the helical gear component, make that my active component. And I'm doing this because I'm going to make a new sketch, and I want to make sure that new sketch exists inside of this helical gear component and is not just kind of hanging out here in my drivetrain component. So I want to try to keep things organized like that. I'm going to create a new sketch. So I'll click on create and then create sketch. I'm going to create that sketch right on the top surface of this gear that I just made, that 16-tooth 2mm module gear. And again, I've got my helical gear component, my active component. So when I click to make that sketch, it's going to create that sketch inside of that component. And I would like to use some existing geometry that I've already drawn. So if I hide the visibility on my helical gear for a second, we can see I've got that shaft already drawn, so I don't need to draw it again. And I just need to take that geometry and project it over. So from the create menu, I'm going to come down here to project include and then choose the project option. I'm just going to hover over that flat face of the motor, and I'll zoom in a little bit more. And you can see it highlights red when I hover over the face of it. And I'll just choose that as the geometry that I'm selecting. And I'll say OK. Now, it's not showing me anything because I've turned off the visibility on that component, so I'm just going to turn that component back on. And now we can see that I've got a nice sketch that is that motor shaft. It's right in the middle of that gear because I aligned it in place when I made that gear, right? I've got a sketch, a new sketch in the sketches folder of my helical gear component, and I'm going to go ahead and name that. This is my, it is my shaft. Shaft. You damn right. Okay, so now we need to extrude this shaft through our gear to create the opening for it, right? So from the create menu, I'm just going to go ahead and choose extrude. And I'm just gonna take that motor shaft and extrude it down. If I look at my model view sideways, I just need to extrude down past the bottom of my helical gear. Now, something I always check when I'm doing an extrude and it's going through multiple bodies is I really only want to be subtracting away from my gear. I don't want to accidentally subtract away my motor shaft, right? Because I'm extruding down into this shape, and I know my motor shaft exists down here, and I don't want to cut that away. So something I just want to double check is in my operation, the objects that I'm cutting, I just want to make sure I have only the objects that I actually want to cut here. And indeed, just, you know, body one inside my helical gear component is the only thing I want to cut. Now, if we were seeing something about our 5-volt stepper motor down here, then we go, oh, I want to uncheck that. But in my case, I'm good to go here, and I can say, okay. So now, we've got a nice hole there, right in the middle of our gear. Is that gonna be all right? That's gonna be all right. All right, and now we can move on to the next gear. So our next gear, we're also going to make it inside of our drivetrain component. So I'm going to go ahead and make my drivetrain component my active component. And let's make another gear. So from the Create menu, we'll go ahead and come down to that Helical Gear Plus add-in that we painstakingly added. Now this I'm going to change from 16 down to 10 teeth. I'll turn the preview on, and let's just we can position it a little bit. So the nice thing about this Helical Gear menu here is it remembers the settings that you used last time. So it's going to remember that 2mm module size. It's going to remember the gear width that I set to 8mm here. It's gonna remember the pressure angle. So if you modified this menu, it will remember that. So you don't have to make weird notes about how many times you're making this gear. So I'm just gonna change the position plane that I'm putting that on. So I'll go ahead and hide my existing helical gear, and then maybe I'll be able to see that plane. And I'm not going to select a center because we're going to kind of manually position it where we need to position it. But I'm just going to go ahead and say, okay. So now it will make that helical gear, and in fact it already has made that helical gear. Here it is. And the reason it's ghosted out is because I need to do the same thing that I did with that previous gear. I need to take this 10-tooth helical gear, and if I click and drag it into my drivetrain, then there we go. It's made that. It didn't move the position, but we'll go ahead and move it for it, I guess. So now I want to take this 10-tooth gear and position it where I need it to be. And I'm going to do that with the Move tool. So from the Modify menu, I'm just going to come down to Move Copy. The object, or the move object, is not going to be a body. We want to move an entire component. I will say moving this body would work. So the goal is to move this 10-tooth gear, right? Moving that body would work. However, I advise against moving a body if it's the only thing in that component. So the reason being is this body is inside of this component here, and this component is associated with sketches and all sorts of different things. So if I just move the body, then I'm moving the body out of alignment with the sketch that made it. And sometimes weird things can happen when you start shifting bodies away from sketches that created them. So instead of moving the body, I would choose to move this Helical Gear component 100% of the time, because moving this entire component will move everything inside of it. It'll move the body, it'll move the sketches, it'll move any associated planes that are inside of that component. So I would choose to move that component every time. And I'm gonna look top down here, and I'm just gonna shift this off to the side a little bit. And this is actually working out really splendidly. Sometimes when you move a gear into place, you gotta rotate it so it looks right, because the teeth won't mash up correctly. And I'm gonna zoom in here just so you can see my teeth are not touching each other, and that will probably be just fine. If you make your teeth touch each other, your gears will probably mash up a little bit too tightly and it'll be a little bit tough to turn. So there's probably an exact measurement that you could give here, but I just make mine look approximately like this. No, nobody's shaking their head in shame at me right now at all, or like cursing me inside.
That's not a perfect spline gear.
I mean, it is a perfect spline gear.
Well, there you go.
I'm just saying I've not spaced it out properly. I'm just kind of eyeballing it, Jeff.
There's actually like an equation for that.
And if you would like to teach a class next week on that equation, I will 100% show up.
I do not. Okay.
All right, so I'm just gonna go ahead and say, oh, you know what? I need to.
I'll show up for
I've
that.
got it. You'll show up for that. We got one taker, Jeff.
I said I wasn't gonna do it.
Oh,
Coward.
Mike, go ahead.
I have half a clear gear and half a fuzzy out of focus gear.
Oh, so I know exactly what happened. So if you got we got one gear that looks fully opaque, and I bet your other gear looks like that. Nope.
Okay, thank you. Sorry.
So I bet your gears look like this.
No. It's much stranger.
Oh, I'm gonna come take a look. We got strange things.
Such as life. So, yeah.
You see how that's nice and sharp and clearly delineated? That sharp is clearly delineated. You see that like shadow thingy right there?
Yes, there is. Before I forget.
You tell me. Absolutely. What? Okay.
So unfortunately, this is not the end of the world.
All right.
You know, so that's the way it is.
Okay.
That way they're all kind of organized, so
Okay.
it just wasn't.
Thank you.
Yeah, it wasn't quite in place. So if you got one gear that looks funny and you've got another gear that looks fine, I would take a look over at your component structure here. So here we've got a drivetrain component, and I thought when you made something your active component that it would make new components inside of that active component. It did not. The Helical Gear Plus add-in does not work like that. So if you've got things that look weird like this, you just need to take this component that is not in your drivetrain component, in your active component, and drag it into your active component, and then it will appear fully opaque. Alright, so the next thing that we got to do here is we need a sketch in our small gear, because our small gear is what we're threading the little turning mechanism for our window blinds. We're sliding that through there, so we need a little hex slot in our drawing here. So we're going to do that the same way we did do the slot, or did the shaft in our 16-tooth gear. So I'm going to make my 10-tooth gear my active component just by clicking the little radio button next to it. And I'm doing that because I'm going to create a sketch. So I'll click on Create and then Create Sketch. I'm going to create that sketch on the top surface of that 10-tooth gear. And right in the middle of that gear, I want to make a circumscribed polygon. Our circumscribed polygon is going to start right in the middle of the gear here, and thankfully for me it made my origin right in the middle of that gear, which is handy. And our radius is going to be 0.32 divided by 2. And so this is the size of the window blinds little hexagonal thing that I have at home. I'm not saying they're all the same, so you may want to, you know, if you're following along at home and you actually want to make one of these weird contraptions, you can measure your little window blinds thing at home. You can also change this later, so it's always easy to change. And I'm gonna click to place that measurement, and then I'm gonna go ahead and say Finish Sketch. So I've got one more sketch to name here. This is my control shaft. I guess that's what I'm calling it. And then we just need to take that sketch that we just made, and just like our shaft, how we made the opening in our other helical gear for our shaft, let's go ahead and extrude that down. So I'll go ahead and, from the Create menu, I'll go ahead and choose the Extrude option. I'll choose that opening from that helical gear and extrude that down. I'm not cutting anything weird, so I'm just going to say OK. Alright, cool. So now I'm going to go ahead and turn off the sketches because I don't need to look at them. And I'm going to make my drivetrain my active component again. So the last thing that I want to do in this class here is to make these gears move, because that's the beauty of Fusion, is or modeling things, is being able to add some motion to them. We already have motion on our motor, so we've got this joint on our motor, and we can add motion to these gears and connect them all to each other so they move along with each other, which is pretty cool. We're going to do that by using the items in the Assemble menu, and really primarily just one item from this Assemble menu. We're going to use the As-Built Joint option. An as-built joint is very similar to a joint, with the exception of, with a as-built joint, all of the parts of your joint are already exist in space where they need to, as opposed to with this joint option, this would be if the parts of your things that you need to move along with each other are separated from each other, and as part of the operation you need to align them with each other. So if the items you have are not already aligned, ours are, you use the joint option, but for us, the as-built joint is going to be the way to go. Now, we are going to be making a joint type that is a revolute joint. And the the order of operations matters here. So the first item that you click on is the thing that is we want to do the moving, and the second item you click on is going to be the stationary object. So if I choose that 16-tooth gear as the first component that I click on, and then the second component I click on is my little 5-volt stepper motor. Now the last thing that I have to do to set this joint is to choose a snapping point. A snapping point basically is the axis that it's going to rotate around, and to choose the axis I'm going to rotate around, if I just find one of the circles, one of the curves of my motor shaft and choose that. Oh, that is not what I want. Oh boy, alright, I gotta do the whole thing again. Revolute. There we go. If I hover over that face of that motor shaft, it knows where the center is apparently. And I just click to place that point, and now my gear's moving around in circles, which is good. If your gear happens to be moving around in a weird way, like if your gear is moving around like that, the thing that is amiss is the axis that you're rotating on. So I'm rotating on my Z-axis, and you can kind of look up in your navigation cube and see which axis you need to rotate around. If you have your X pointed up, you'll need to rotate around your X-axis, but again, for me, it's my Z-axis, and that's going to work out just great. Alright, so I'm going to go ahead and say OK, and let me do that one more time. So I'm going to do the same thing for my small gear here. So from the Assemble menu, I'll go ahead and choose this As-Built Joint option. I'm making a revolute joint, and the first item that I click on is going to be this small gear here. And now I'm actually going to choose to click on as the second component in this joint. I'm going to choose my stepper motor again. So it would be tempting to choose this gear, the larger gear, as the point of rotation. Oh, I don't have anything to click on, do I? Here we go. Will that work? It almost wanted to click on the center of that gear. Ooh, there we go. So if I hover over just the right point of that curve, you can see it wants to choose that as my center point. Something that you can do if you're having an issue, I happen to know that I have a sketch, and our sketch, as part of it, we made a center polygon. That polygon has a center point, so if you're having trouble finding the center of this small gear, you can turn on your sketches inside of that 10-tooth helical gear. It's really just a regular gear, it's not a helical gear, I keep saying that. And we'll just turn on our control shaft sketch. That is that sketch that you see there. And that makes it easy for me to find the center point. And then I'm going to go ahead and say OK. Now I've got two gears these two gears will move. However, they don't move in conjunction with each other. And the last thing that we need to do here is to add that, what do we call it here? To add that motion link. Mike, did you have a question?
No.
Okay, cool. All right, so from the assemble menu, if we choose this motion link option, and I choose the joints that I want to link together, I can either highlight them, the little blue flags, I can highlight them out here in my drawing view, or, because they're a little hard to click on, I can click on the joint in my joints folder. So as we've been making these joints, it's made a joints folder inside of our drivetrain component, and I can click on the two objects there. So obviously this is not working correctly, and that's because we need to change a couple of things. So first, I need to reverse the direction that that link goes. So if I click the little reverse button, now I can see when one gear is moving, the other gear is moving the right way. And I have one of these that is 16 and the other one is 10 teeth. So there's a ratio that's happening there, and I just need to experiment with which one is which. There we go. So for me, if I change one of these angles to 10 degrees and the other to 16, then it looks like it's meshing the teeth properly. The only way that I can tell you is to experiment with that. So I know I've got 116 and 110 tooth, so those numbers are pretty easy to figure out. But I just have to do a little trial and error. And you can see one way clearly is not working out good. One way is moving way too fast. And if I change that ratio to the opposite, then it moves along real nicely. All right, I'm gonna go ahead and say okay. And I'm gonna do that one more time. So let's go ahead and name our joints. This is our 16 tooth, our Rev 2, this is our 10 tooth. I just like to name things. This motion link here, this is our 16 tooth to 10 tooth. I'm going to add one more motion link because here you can see if I double click on this little gear, I can rotate this around. However, our motor shaft isn't rotating when I do that. So I just like to add one little link there connecting the joint that we already made in the other component or in our other document to this document here. So from the assemble menu, I'll just go ahead and choose that motion link one more time. I'll choose the joint that is our motor shaft, and I'll choose the joint that is our gear. And you can see I did that in the wrong order. So like I said, the order matters. So the first thing I have to click on is the thing that I want to do the moving, in which case is going to be our big gear here, our 16 tooth gear. There we go. Now that's moving nicely. And this is just a one-to-one option, and I don't have to choose reverse here because it's going to move in the same direction. And now I'm going to say okay. So I think that is going to be it for this section here. The last thing that we need to model is the sheet metal portion of this design, or the thing that I'm choosing to make with the sheet metal area of Fusion 360 here. So you can kind of see that this is the design we're working towards here. And I've got version 1 of the hardware going on right here. I'll show you in person. But you can see we've got our stepper motors right here, and then we've got our gears, and then through the center of this gear is our control rod. So like I said, on my curtains, do you guys have curtains like this at home? Mike, do you have curtains like this?
No.
Window blinds? No window blinds? Does anybody have window blinds at home? Raymond, or you do?
Yeah.
Sweet. All right, there are 2 of us that this applies to. So I've got this working at home. It's pretty cool. I've got 2 windows that I can tell Google to open for me now, and I'm kind of excited about it. So we're gonna do this sheet metal thing next week, and then we'll see if people are interested in the electronics side of things. I know we might have one person who's interested in the electronics side of things. But you know, if more people are interested, we'll put out the poll next week. But like I said, next week we'll do sheet metal. We'll make this bent piece. This was version 1, and I decided to switch to this like bent sheet metal thing because I think it'll look cleaner. So version 2 looks a little nicer, and that's what we'll be finishing up the design of next week. Cool. Anybody have any questions before we wrap up? You guys are good at home?
All good.
Beautiful. We'll see you guys next week.
See you next week. Thanks, Carl.
All right. Thanks for being here, guys.